Welcome to Unit 3. This unit's called Comparing and Scaling in the textbook. So, we're going to be discussing more ratios and proportions. Okay, there's going to be a lot of that going on. We're going to be touching back on percents, talk about some fractions, scaling, what differences are, and then we're going to hit rates and unit rates pretty hard in this unit. Okay, so let's say that a class has 12 girls and 15 boys. So if I ask you a question of what is the ratio of girls to boys, and again, this is review. What is the ratio of girls to boys? You're going to write your ratio in one of three ways. You're either going to write it as 12 to 15 with the word 2, 12 to 15 with a colon, or 12 over 15 as a fraction. Now remember, we're talking about boys and girls in a class, okay? So if I have a class full of boys and girls, then we're looking at two parts that make up a whole, right? If the class is the whole thing, then the boys are part of the whole thing, which is the class, and the girls also make up part of the whole class. So if I'm comparing boys and girls to each other, then I'm making a part-to-part comparison, okay? I'm comparing two parts of a whole. Because remember, if I have a classroom, I've got boys in it and I've got girls in it. So if I ask for the ratio of boys to girls, you could say it's 15 to 12. And if you reduce it, you'd get 5 to 4. I could have also asked for a part to whole ratio, okay? What if I asked you for the ratio of boys to the whole class? Well, how would you get that? Well, if I have 12 girls and 15 boys, how many students are in the class? There's 27, right? And if I have 15 boys, then my ratio of boys to the whole class is 15 to 27, okay? Because remember, this 15 represents boys, and since there's 12 girls, that means that the whole class is 15 plus 12, which is 27. So the class is comprised of 27 students. Differences. Remember, when we talk about differences, we're talking about subtraction, okay? You're comparing how much more or less one quantity is than another. We find this again by subtracting. For example, if I ask what the difference is between the number of boys versus girls, you're going to tell me that the difference is 3 because there's 3 more boys than girls. And that's exactly what you would say if I asked you, what is the difference between the amount of boys versus girls, or the number of boys versus girls? You could respond in one of 3 ways. You could say there are 3 more boys than girls. You could say the boys outnumber the girls by 3. Or you could say that there's a difference of 3 between boys and girls. A little bit more review. Let's talk about scaling. Remember, when we're talking about scaling, or a scale factor in this case, it's the number that's being multiplied by one quantity to get another. When we had sides, we multiplied the sides by the scale factor to get the sides of the new figure, okay? We went from the pre-image to the image. How do you find the scale factor? Well, we always found the scale factor, especially in more complicated situations where the scale factor was a fraction. We found it by doing division, right? If I was going from 2 to 3 and I asked you, well, how do I make 2 become 3? What am I multiplying 2 by to get 3? You would always tell me that you had to divide 3 by 2, which just gave me 3 halves. Okay, just because we're dividing doesn't mean we have to actually divide it out. Sometimes you can leave it as a fraction. Here's an example. Jane is 6 feet tall and Tom is 3 feet tall. How many times taller is Jane than Tom? Well, Jane's twice as tall, or 2 times taller than Tom, because 6 divided by 3 equals 2. That's my scale factor. Let's talk about some fractions. Fractions compare parts to a whole. If I have 3/4 of something, that means the whole thing is split into fourths, and I have 3 of them. If I have half of something, that means I have 1 out of 2 parts, okay? Each half is a part. The whole thing, when I combine the 2 halves, is the whole. So if I ask you what fraction of the class is comprised of boys, you would have told me 15 out of 27. 15 is the part, and 27 is the whole. Again, if I ask what fraction of the class is comprised of girls, then you're going to tell me that it's 12 out of 27, right? Because 12/27ths is the fraction that you get of girls over the entire amount of students in the class. And then our old friend, percents. Remember, percent means out of 100. So if I have 30%, that means I'm taking 30 out of 100. 72%, 72 out of 100. 400%, that's 400 out of 100. Remember, we can use percent ratios that we learned in Unit 2 to find a percent. Some of you had your own ways of finding percentages. That's fine too. Okay. Let's look at this example. We have 25 chocolate cookies. We have 20 vanilla cookies. What is the ratio of chocolate cookies to vanilla cookies? And then tell me what it is in lowest terms, okay? Reduce it as much as possible. Well, right off the bat, you should have been able to tell me it's 25 to 20. And 25 over 20 can be reduced by 5. So you get 5 to 4. What if I asked you how many more cookies are chocolate than vanilla? This question is just like me asking what is the difference in the amount of chocolate versus vanilla? Okay, so how many more cookies are chocolate than vanilla? 5, right? 25 minus 20 equals 5. Let's look at another one. What fraction of the cookies are vanilla? What fraction of the cookies are vanilla? Remember, there were 20 vanilla cookies and 25 chocolate cookies. So if I combine the two, vanilla and chocolate, these are both parts. Remember, chocolate cookies, vanilla cookies. These are both parts of a whole, the whole thing being just cookies. So if I combine the two, 25 and 20, I get 45. So that's my grand total. So the amount of vanilla out of the entire amount of cookies is 20 out of 45. And that reduces to 4/9 because 20 divided by 5 is 4 and 45 divided by 5 is 9. What if I asked you what percent of the cookies are chocolate? Okay, what if I asked you what percent of the cookies are chocolate? Again, you can use a percent proportion. In this case, you would do 25 over 45 because there's 25 chocolate cookies. There's 45 total cookies. And you would set that equal to x over 100 and make your proportion. When you figure out the rest of this by dividing or cross multiplying and then dividing each side by 45, you end up with about 55.6%. Okay, because remember, you get 0.55 repeating, or you get 55.5 repeating, and you end up with 55.6%. Now, if you're wondering what I would accept, it would depend on what the directions say. I might tell you to round to the nearest tenth. I might ask you to round to the nearest whole percentage. Okay, or you could have left it as a fraction. How many times more chocolate cookies are there than vanilla? Okay, remember we're talking about how many times more. So we're talking about multiplication, and to undo multiplication, we have to divide. So if I'm talking about how many times more chocolate cookies there are than vanilla, I'm going to take my 25 chocolate and divide it by the number of vanilla. And we already know that 25 over 20 is 5/4. So if you left it as that, that's fine. You could have left it as 5/4. You could have made it 1 1/4. You could have written it down as 1.25. Okay, they mean the same thing. Whether you left it as an improper fraction, a mixed number, or a decimal, they all mean the same thing. So let's look at a table. Okay, now when I'm reading this table, I'm noticing a few things. This column has boys and girls, right? As I'm going through each row, these two rows have numbers and they're representing hamburgers, hot dogs, and pizza. So to give you a little bit more context about what this table represents, it represents the amount of boys who like hamburgers, boys who like hot dogs, and boys who like pizza versus the amount of girls who like hamburgers, girls who like hot dogs, and girls who prefer pizza. Okay, so as I'm looking at this, for boys, there's 25 who like hamburgers, 15 who like hot dogs, 60 who like pizza. There's 26 girls who like hamburgers, 19 girls like hot dogs, and 55 girls like pizza. So let's look at this. First question says, what is the ratio of boys who like pizza versus girls who like pizza? Well, that's easy. I'm going to look at the column that says pizza. First number is boys, second number is girls. My ratio says boys to girls, so it's 60 to 55. If I wanted to reduce that, I would get 12 to 11. Okay. Now, when do I know to reduce versus not reduce? If I don't tell you that you need to reduce, you can just leave it as 60 to 55. In terms of how to write it, if I don't tell you that I want a fraction, you can leave it as 60 to 55. You can write it as a fraction. You can write it with a colon. Okay, remember there's 3 ways of writing ratios. If I don't specify, then just write it however you prefer. What about the girls who like hot dogs outnumber boys who like hot dogs by how many? Okay. The number of girls who like hot dogs outnumber the amount of boys who like hot dogs by how many? Remember, when we're talking about outnumbering, we're talking about what? The difference, right? Remember, you should be writing all these terms down that we're talking about. There shouldn't be a point where I mention a term and you go, what does that mean again? You should have it written down and you should be looking at it in your notes. So if I'm talking about differences, I know that 19 girls prefer hot dogs and 15 boys prefer hot dogs. So 19 minus 15 gives me 4. Here's a good one. What fraction of the students like hamburgers? What fraction of the students like hamburgers? Well, how do I know how many students there are? I have to add up everything, right? The amount of boys that like hamburgers and girls that like hamburgers, plus boys that like hot dogs, girls that like hot dogs, plus boys who like pizza and girls who like pizza. And if I add all that up together, I believe that gives me 200. So I have to figure out what fraction of the students like hamburgers. Well, how many students like hamburgers? 25 boys and 26 girls. How much is that total? Good, 51. So I get 51 out of 200. Okay, that is my fraction. What percent of students like pizza? Well, I can set this up in my percent proportion. If I'm looking at pizza, there's 60 plus 55. That makes 115. So 115 out of 200 equals X, which represents my percent that we're looking for, over 100. Well, 100 goes into 200 twice. So if I divide 115 by 2, I get 57.5%. Okay, 57.5%. How many times more boys like pizza than girls? Remember, when we say how many times more, we're talking about multiplication, and we're going to undo that multiplication with division to figure out how many times more boys like pizza than girls. So we're going to take the amount of boys and divide it by the amount of girls. So we get 60 divided by 55. And if I divide 60 by 55, I can reduce 60 over 55 to 12 over 11. And I could leave it that way. You could have also said 1 and 1/11th, which is great. And if you divided it, I believe you have to round this one to 1.09. So again, try to leave it as a fraction as much as possible so that you get an accurate answer. Rates and unit rates. So this one's the part that's not review, okay? Everything else up till now was review. So hopefully we know all that. Rates and unit rates. Part of this should also be review because I believe that you guys did this in 6th grade math. So let's talk about all of these things. So a rate is a comparison of two quantities that have different units. So what's the difference between a ratio and a rate? Well, if I have a ratio, I just have two numbers that I'm comparing. 90 over 3, okay? 90 to 3. If I have a rate, I'm comparing two quantities or two numbers that have different units. So 90 miles per 3 hours. And again, you read this as 90 miles per 3 hours. When we're talking about rates, we're talking about per something. So what does this help us with? What does this mean? Well, let's look into unit rates. We know what a rate is. A rate was a comparison of two quantities that have different units of measurement. A unit rate, however, is a rate in which the second quantity or the denominator is 1. Okay. When we're talking about unit rates, we're talking about per 1 unit of something. So if we're talking about 90 miles per 3 gallons, we want to reduce that so that it's out of 1. See how right now it's out of 3? We want to reduce it so it's out of 1. And sometimes it works perfectly, where I have 90 divided by 3. Sometimes you're going to get a fraction or a decimal. Okay. Now, 90 over 3. 90 divided by 3 is the same thing as 30 over 1, or just 30. And if I change that to my unit rate, because it was 90 miles per 3 hours, I still keep hours and miles in the same places. So this now becomes 30 miles per hour, or 30 miles per 1 hour. So let's look at another example of unit rates. So Fred can type 30 words in half a minute. How many words can he type in 1 minute? It's fairly simple, right? This one says that we've got 30 words in half a minute, and we want to figure out how much it is in 1 minute. So apparently this doesn't work as well on my iPad, so bear with me. So it says 30 words over half a minute. I know to get half a minute to become 1 minute, this 1 should be down here, so I apologize. In order to make that happen, I need to be able to multiply 1/2 by 2, because that gives me 1, and 30 by 2, which gives me 60. So if Fred can type 30 words in half a minute, then he can type 60 words in 1 minute. Okay. So I believe I fixed that glitch. So here we go. Again, Fred can type 60 words in 1 minute. So in this example, Penelope can type 90 words in 2 minutes. How many words can she type in 1 minute? So to figure this out, we know that Penelope can type 90 words in 2 minutes. So she can type 90 words in 2 minutes. How many words can she type in 1 minute? So she's got 90 and 2. If we're trying to make this per 1 minute, well, how do we get 2 to become 1? We divide by 2, which means we have to divide 90 by 2 to get 45. So if she can type 90 words in 2 minutes, then she can type 45 words in 1 minute. And that's exactly what your answer would be. Penelope can type 45 words in 1 minute. What about unit price? What in the world is that? Well, if a unit rate is a rate per 1, then a unit price is the same thing as a unit rate, except now we're comparing the price for 1 item, okay? So what does that mean? Well, let's look at it this way. If I can buy pens in a 5-pack for $1.95 versus a 15-pack for $6.20. Now this is an easy one, so I get how you can go the opposite direction. But in order to figure out which one the better buy is, you can solve this by getting the unit rate. Well, how do I get the unit rate? I figure out how much 1 pen is. So if I'm paying $1.95 for 5 pens, then if I divide $1.95 by 5, what do I end up getting? I end up getting about, and not about, I get exactly 39 cents. What about in this case? So this 39 cents represents how much 1 pen equals. In this case, I'm paying $6.20 for 15 pens. How much is that per pen? It's about 41 cents, okay? Now, if you try to divide $6.20 by 15, you're going to get 0.41 and a third, because it's going to be 3 repeating right after the 1. Okay, so you're going to get 41 cents and a third of a cent. So because a third is less than a half, you're going to round down. So you get 0.41 or 41 cents per pen. Well, what's the better buy? The 5-pack, right? You end up saving more money per pen. The better buy is the 5-pack for $1.95. What about here? It says Jamie can buy a 15-ounce jar of peanut butter for $2.19 versus a 20-ounce jar for $2.78. Which is the better buy? Which one is the better buy? Well, I can do the same thing here. I can take the price for the jar, which is $2.19 per 15. $2.19 divided by 15 gives me approximately 15 cents per ounce. Same thing here for the 20-ounce jar. It's $2.78 per 20 ounces. If I divide that, I get 14 cents per ounce. So 14 cents is less. So the 20-ounce jar is actually the better deal. How about this one? And again, you can pause this to solve this one on your own. Golf balls can be purchased in a 3-pack for $4.95 or a 12-pack for $18.95. Which one is the better buy? So again, you can pause this and solve, and you can check back with this. So if we compare the two, $4.95 for a 3-pack is the same thing as $1.65 per golf ball. And $18.95 divided by 12 gives me $1.58 per golf ball. So the 12-pack ends up being the better buy. Try this one on your own. John can buy a 24-ounce bottle of ketchup for $2.19 or a 36-ounce bottle for $3.79. Which one's the better buy? So you can pause this and solve it. Price for each bottle over the number of ounces. So it's always the price over either the amount or the number of whatever we're talking about, pounds, ounces, whatever. In this case, it's $2.19 for a 24-ounce. If you divide that out, you get about 9 cents per ounce versus $3.79 divided by 36, which gives you about 11 cents per ounce. So the 24-ounce bottle of ketchup is the better buy. Now, when we're talking about rates, we can use something called a rate table. Okay, a rate table helps us figure out the answers to certain questions. So, for example, if I know that 3 sweaters cost $18, what is the cost of 7 sweaters? Well, if I use this rate table, I know that 3 sweaters, that's the number of sweaters, costs $18. This represents my dollars. So if 3 represents 18, how can I use this table to help me out? Some of you already probably thought about it. If I know that 3 is 18, then I know that 1, which would go up here, costs what? $6. And if I know that 1 costs $6 and I need to know how many 7 cost, well, guess what goes in here? Exactly, 7, which ends up giving me $42, right? Which means that 7 sweaters cost $42. All right, well, that's it for now. If you have any questions, please let me know, because again, if you don't ask, who else is going to clarify for you? Even if you're not asking me, you might be asking a parent, you might be asking a tutor, whatever, okay, or a friend, but ask questions, because if you're confused about something, you're not going to get any sort of clarification, and I don't want that to happen. Okay, so ask me if you have any questions. All right, thank you.